So I want you to have your little organizer off to the side as well as the notes, because what I'm going to do is kind of explain where one of these comes from, and then we'll write down the rule, and then I'll explain another one and we'll write down the rule. This might take a little bit longer, but I like to do this instead of me just throwing all of these at you and being like, here, memorize them. I like to show you at least a little bit of the explanation of where they come from. So, humor me. I don't like here, memorize this. I like to explain sort of where it comes from. So this is your graph of sine. How do you know this is sine and not cosine? Starts at 0, starts at the origin. Your critical points are at pi over 2 and 3 pi over 2. Do you remember the little envelope activity where you matched together f and f prime and we were graphing derivatives and all that happened last unit? So those are your critical points that you can put over here on your derivative graph. We're going to graph the derivative. If you remember, we actually did this one already. I tricked you into doing it already. So do you see how we're positive, negative, positive? How this is increasing, decreasing, increasing. So we want to be above, below, above. So we are going to be above the x-axis, like above sea level, below, and then above. And it's going to keep going above, below, like a little sea serpent forever and ever. And so what is that the graph of? Cosine. So the derivative of sine is cosine. So we're going to go over to our little bubble sheet. Again, we're just going to keep going back and forth. So we're going to put all the trig right in here. You're going to want to write fairly small. I did leave you enough room, but there are 6 trig functions. I don't like to say this ahead of time because I don't want to startle anybody. There are 3 of the arc ones that you have to know too. I am the messenger. It is all the standards are up there if you want to look through them. I'm just here to let you know. All right, so d dx, that is instructions that mean take a derivative. That's like, here, do this. So derivative of sine is cosine. Usually once we get to the trig is where I tell people to start making some flashcards. It's like once we get through this one, there's a bunch. So like at this point, you might want to start making some flashcards. So derivative of sine is cosine. All right, let's do the next one. Here are your critical points. So we have critical points at 0, pi, and 2 pi. And then obviously like forever and ever, keep on going. So that's where you have your zeros on your derivative graph. Do you see how this is going to be below and then above? You have negative and then positive, right? So we're going to be below sea level for this part. And then above. And then it's going to go below, above, below, above. I want you to look at that and think about it. What is that the graph of? Why? It is sine because it starts at the origin, but why is it negative sine? Because it's flipped, reflective or x-axis. So go ahead back to your bubble sheet. And we're going to write derivative of cosine is negative sine. Cool. We hung in there so far. Remember, just pick up where we are. I'm recording this. You can always watch the minute that you missed. Okay. Just pick up where we're at. All right. Here's your graph of tangent. It's not showing up in the graph because they're invisible, but you have asymptotes at pi over 2 and 3 pi over 2. If the graph is not continuous, it will also not be differentiable. So if we can't have continuity there, we're not going to be able to get a derivative at those points. So you're still going to have an asymptote at pi over 2 and 3 pi over 2. That's not going to change. If your graph is not continuous, it's not differentiable, meaning you cannot get a derivative, like by definition. So watch me point to this. Do you see how this is increasing and then still increasing and then still increasing? That means over here, my graph should always be where? Above. Should always be above sea level. And it never quite gets down to 0. You don't have any actual horizontal tangent lines. Do you see how it almost goes down to 0, but not quite? It's actually a slope of 1 at those points there. So this is what it's going to look like. You're going to start at 1 and it's going to stay above. It has nowhere else to go except the asymptote. And then you're still going to be above. It's going to come down to a slope of 1 and then still be above. So it's going to look like that. And then another one, and you're going to get all these U shapes forever and ever and ever. Do you remember? I don't expect you to remember which one this is, but do you remember which 2 trig functions were the U shapes? It's cosecant and secant. This is the graph of secant, but what? Like, what's different about it than the actual graph of secant? They're all positive. How do you turn a number positive? There's actually 2 ways, but there's one that's You square it. What's the other way you can turn something positive? Absolute value. That's not what we're going to do here though. So square it, keep it positive. You take two, can't talk. It's Friday. To keep it positive, you're going to square it. So this is the graph of secant squared. It's the secant graph, but it's always positive. So when you go and put that on your little bubble sheet, your derivative of tangent is secant squared. And at this point, I am going to go off on a tangent for a second and talk about putting that little squared in there because you have to understand the difference. Do you get the difference between this? You don't have to write this down. We're going to do plenty of examples of it. But do you see the difference between those? Okay. This means secant times secant. You've actually squared the secant function. This means secant of x times x, like you've squared the x. It looks very subtle, but that is a very deep-seated difference. Do you see what I'm saying there? Like it matters, okay? Don't talk to hear myself talk. I'm bringing it up because it matters, okay? And then there's one more I'm going to kind of explain to you, and then I'll just tell you the last two. Does anyone remember with your identities how you can rewrite cosecant? You can write it as 1 over something. It's not good. If you were with me, we played a bunch of Quizlet. No, it's not that simple, unfortunately. We're going to do a quotient rule. If only, right? No, it isn't. We're going to do a quotient rule. You can't do that. Just algebraically, that doesn't mean the same thing. All right, so how does quotient rule start? All right, denominator, good. Now, derivative of the numerator. Derivative of just plain 1 is 0. Minus what comes next. That bothers you guys way more than me. If you're awake and talking to me, I am thrilled. If you are awake and talking to me, I'm thrilled. I don't care if you say a wrong answer. I'm happy if you're talking to me. All right, derivative of the denominator. What is the derivative of sine? Cosine. And then it's over the denominator squared. Ooh, where will the squared go? Yeah, right after the sine. You're squaring sine. It's sine of x times sine of x, which is actually how I'm going to write it in this next step because I would like to simplify this down. This whole first part is gone. That's all, 0. That's all nothing. So in the numerator, we have -1 times cosine of x. I'll explain to you why I wrote it like that. You're like, Miss Cole, I don't want to write the 1. Write it for just a second. Humor me, okay? And then down here, sine squared means sine times sine. Sine times itself. So what would -1 over sine simplify down to? It'll be negative cosecant. Good. I knew what you meant. And then does anyone remember what cosine over sine simplify? Cotangent. Good. The way I remember that one, usually sine over cosine is tangent. I don't know why, but everybody remembers that one. The way I remember this one is see how the co is on the top? That's how I remember that one's cotangent. I don't know why, but that's how that sits in my brain. That's how I remember that. But anyway, that is the answer. Your derivative of cosecant is negative cosecant cotangent. Let's put that on our bubble sheet. So derivative of cosecant is negative cosecant cotangent. And I'm going to just tell you the last two. I feel like I did a good enough explanation of where these are coming from. You could do more quotient rules to get the others, but I'm going to just give them to you. Which one would get written here that we usually write across from cosine? Yeah, secant. We usually try to line up the reciprocal ones together. I almost said inverse, which is not right. Inverse and reciprocal aren't the same thing. We know that, right? That's a totally different conversation for a different day, though. Cosine and secant are reciprocals. So your derivative of secant is secant tangent. There's not, I'm going to talk about that. Once I write the last one, I'm going to kind of wrap it all together and tell you how I remember it. There's a million different tricks though that people come up with. You kind of have to do what sits right for you in your brain. And then the last one is cotangent. That is negative cosecant squared. So I'll explain to you how it works for me. And then I'll show you a trick that a student brought up to me one year. I call them buddies, okay? Because we don't have a special word for this, but do you see how sine and cosine are buddies? They go together. Do you see how tangent and secant are buddies? They have each other in their derivatives. And then do you see how cotangent and cosecant are buddies? They have each other together. Which ones get the negative? Which three are getting the negative in their answer? Cosine, cosecant, cotangent. So if it has a co, it gets a negative. That's how you can remember the negative. And then do you see how tangent and secant have the same type of relationship as cotangent and cosecant? Like this one is secant squared and this one's negative cosecant squared. Like those both have the squared. And then these just have each other. I'm telling you how I kind of think of it. Here's the other thing a student gave to me once. Let me see if I can remember it right. I think it was psst, like, hey, psst, I'm gonna tell you something. Okay. The P stands for positive, and then you cover up the one that you want. So like if you want tangent, if you cover up the T, do you see how they're both S's? It's secant squared. If you cover up one of the S's, do you see how it's secant tangent? And it's positive? For what it's worth, but there's not a cute acronym for the other one. I think we tried to come up with it and it was like cacect or something. I don't know. I can't remember. It didn't like spell a word though. But anyway, there they are. Let's go practice them. None of the other rules went away. Product rule, quotient rule, chain rule, all still in play. What rule is this one? Good. Okay, you guys are on top of that. All right, x squared is the first thing. Sine of x is the second thing. Oh, we're doing great on time. It's gonna get long horizontally, so start like all the way over at the edge of the paper. How does product rule start? The first function, the first thing. So x squared. Derivative of the second. So derivative of sine, cosine. I don't expect you've memorized them yet. I literally just taught them to you. Just keep your little bubble sheet off to the side and you can look back at it. All right, plus the second thing times derivative of the first, which would be what? 2x. That's it. This one is not a product rule. You don't have cosecant of x times something else. What is going on here? Like, what rule is this going to be? It is like cosecant got hungry and ate 2x squared plus 3. This is all inside of that. So it is a chain rule. So you do derivative of the outside. The outside function is cosecant. Again, I don't expect you memorized it yet. Look back at your bubble sheet. It's going to be negative because it's a co. It's negative cosecant cotangent. Here's the thing. It's negative cosecant cotangent of said guts. It's of that stuff. So it's negative cosecant of blah, 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 cotangent of blah, blah, blah. And curses on this hole that's in the paper, because I could easily have made this fit. Chain rule dot, and you're going to chain on the derivative of the stuff in the parentheses. So that would be 4x. I'm pausing there to let that sink in and see if there's a question or y'all still in there. All right. What rule is this one going to be? Chain. There are actually 3 links in the chain this time. The way I always think of this, do you ever watch a cartoon when you were little when like a medium fish comes by and eats the smaller fish and then a big fish comes by and eats like that one? It's like all links in a chain. That's what this is going to be. The most outside function is the 4th power. Inside of that is the cosine. And then inside of that is the 9x. So there's 3 functions going on. So first thing you're going to do is bring the 4 down. Everything else stays the same and it drops to a 3. So you did a power rule. You bring the 4 down. Remember, the guts stays. You don't change that. All that stays the same, drops to a 3. Chain rule dot. Now I'm done with the 4th power. Just going to try and cover that up for you there. We're not using that anymore. We took care of it. Now we're on to cosine. What's your derivative of cosine? So it's negative sine of that stuff. And then lastly, so you get another chain rule dot. There's another link in the chain. Then you chain on the derivative of 9x, which is just 9. Believe it or not, that's all one term. That's all just multiplied together. That's all one thing. You got it. It's gonna be okay. I'm gonna start number 4 down here because if I start it here, I'm gonna run off the paper. So I'm gonna come down to the next line. Now this is 2 separate terms. You have secant, and then separately you have tangent squared, separated by a subtraction sign. So this is literally just derivative of secant. Again, I don't expect you memorized it yet. Look at your sheet. Derivative of secant is secant tangent. And it was just x. There was no chain rule. It wasn't like secant of more stuff. Like that was it. Minus, now what rule is this going to involve? Good, chain rule. You have the power, and then you have the trig function. So you're going to bring the 2 down, and it drops to a 1. I highly recommend writing the 1. If you don't, you're going to be like, what happened to it? Okay, so just write it. And then you chain on the derivative of tangent. Secant squared, good. Again, you didn't memorize them yet. We're working on it. Like this is your first try at it. All right, what rule is this one? Quotient. So we're going to start with denominator. And then times what? 4, good. Derivative of the numerator. Minus 4x, which is your numerator. And then derivative of the denominator. Now it's a so it's going to be negative cosecant squared over the denominator squared. Yay, good job, you did it. All right, one more of these and then we'll have to go back to the bubble sheet so I can tell you the inverse ones, the arc ones. What rule are we going to need for this one? Product rule and chain rule, because this isn't just sine of x, it's sine of more stuff. In your product rule, the first thing is that sine of 5x squared. The second thing is secant x. I am definitely not going to fit this in. I'll have to go down to the next line. It's whatever. All right, so product rule is the first thing. Just be careful with your parentheses because there's kind of a lot of them. Lots of hugs here. All right, so first times derivative of the second. So what is your derivative of secant? Secant tangent. Plus, and I'm going to have to come down to the next line for the part after the plus sign. I'm sorry, I know there's a bad glare.
No, it's okay.
Is that better? I tried turning off a light yesterday and it still didn't help. Is it better like if I move it down?
Yeah,
okay,
that's fine.
Okay. So first times derivative of the second plus the second thing, secant x, times derivative of the first. Now this is where you have a chain rule. It's like sine got hungry and ate 5x squared. So you're going to do derivative of sine, leave the guts alone, and then do a chain rule. So what is your derivative of sine? So it's cosine 5x squared, little chain rule dot, and then what's your derivative of the insides? 10x. Good. All right, go ahead and go back to your bubble sheet, and I'm going to give you the 3 arc ones that are fair game. Yeah.
For something like this, couldn't you just put parentheses and then square it out?
Yes, yes. So you could put parentheses cotangent and then the squared outside. Means same exact thing. All right, so we're gonna do derivative of arc sine. We're gonna do derivative of arc tangent. And it used to be that those were the only 2 arc ones that would show up on the AP exam. And then in like recent years, arc cosine is now like fair game too. So I'm going to just go ahead and show you that one. It's not super likely to come up. This isn't something that like when you're preparing for the AP exam that I would spend an inordinate amount of time on. Like it's a lesser topic, but that doesn't mean I'm not going to teach it to you. You know what I mean? I'm still going to show it to you. You aren't going to like these ones, but all right, this is 1 over a square root of 1 minus x squared. And then this one, arctangent, is 1 over x squared plus 1. What I usually tell people is you have a choice, and you always have a choice. They might throw one of these on the multiple choice of the AP exam. And you can choose to try and memorize it, or you can choose to guess when you get to that one question. Do you know what I'm saying? Like it's your choice. This is a lesser kind of topic, but I'm still going to show it to you. Here's the only saving grace. Arc sine and arc cosine are the exact same thing, except what do you think the cosine one is going to have? A negative. So it's this exact same thing, but negative. So if you bother to remember arc sine, arc cosine is the same thing with a negative in it.
So, and you have like an adventure.
For here?
Yeah.
Well, I pulled questions from AP Classroom, but I don't remember everything in the whole world. There might be one. You know, like I'm trying to make your tests mimic the AP exam as much as possible. The only thing is they're on one unit at a time instead of like the whole test. But yeah, I mean, they're fair games. So yeah, one on there, yeah. And watch when we write it. I know that looks scary, but it's not actually all that hard. You'll see it's not that bad. I know we like to complain, and that's human, so that's fine, and you're allowed to do that. My feelings aren't hurt. I didn't invent this. Not my information. So arctangent is going to be 1 over. Now I know the rule said x squared plus 1, but when you're doing an actual problem, it's going to be this stuff squared plus 1. And then there's a chain rule. So put a little dot, and you would chain on the derivative of that stuff, which would just be 7. Now, when you see like that in a multiple choice scenario, it won't look like that. Where would they put the 7? Yeah, so the 7 would go on top, and then they would evaluate this. So 7x to the second, it would be 49x squared plus 1. So like that's how you would see it written. Again, it's not that hard. It's just one more thing to memorize, which is the problem. It's too much to memorize. Nothing in calculus is really all that hard by itself. It's when you put it all together, it's just too much. It's such a large quantity of information, you know. So arc sine, it's going to be, well, let me write f prime here. I don't want to start slacking. All right, 1 over square root. And again, the rule said 1 minus x squared, but it's going to be 1 minus this stuff squared. I'm going to try and get you to make the leap. What would we get if we squared all of that? Yeah, 9x to the 4th. Good job. And then you would chain rule on. So you could put a little dot, but I'm actually going to just put it in the numerator. 6x. Good job. Yeah, see, this is not that bad. It's just one more thing.
Would that be like we're not like it says it's the square root, but it would be like on the side.
Yeah, you could write it off to the side, but like you won't get one of these on free replies. As I say that, then this year it'll happen. If it's in multiple choice, they're going to write it this way. All right, and then I threw a few with like words in them, so you have to know vocabulary. This says write the equation. What do we need? A slope and a point. So your point of tangency is pi over 3. You're going to have to know the unit circle. My favorite. All right, so if you plug pi over 3 into this, what immediately is going to happen to the 3's? You've got this. They cancel and it's just pi. Where on your unit circle is pi? Up, down, to the left. Good. The point -1, 0. Cosine is the x part of the point. So this would be -1 to the 5th. Now, is -1 to the 5th -1 or +1? -1. Good, because 5 is odd. It means -1 times -1 times -1 times -1 times -1. All right, slope comes from the derivative, so we're going to get the derivative and then plug in pi over 3. This is the one where there's 3 links in the chain. What's the most outside one? Which one are we going to do first? Good, perfect. So you guys listen to me, now you got it. 5, and then it'll be cosine to the 4th of 3x. All the rest stays the same. Now, if it's a squared and you bring down a 2, please write the 1. You're going to confuse yourself if you don't write it if it's a 1. All right, chain rule dots. Now we're done with the 5th. I'm going to cover it up. Now we're doing derivative of what? Cosine. What's your derivative of cosine? Good. So it's negative sine 3x. So I know you guys aren't happy about it, but you've got it. And then chain on a 3. So we're going to plug in pi over 3, see what our slope is. So let's see. Here we're going to have 5 times something to the 4th. If you plug in pi over 3, again, the 3's cancel, it's just pi. Oh, so same thing, negative 1. Times. If you plug in pi over 3, the 3's cancel, it's just pi, but this time it's sine. So think pi is over here, it's the point negative 1 comma 0. So sine is 0, and then just times 3. So I have really good news for you. That whole thing comes out to 0. Which means, this is interesting, the tangent line is what? Horizontal. But flat means this. Horizontal. But let's put it all together. It would be y plus 1 equals 0, parenthesis, x minus pi over 3. I realized this would all be 0, so if you really want to dig in your heels and be like, Miss Cole, I'm not writing it, fine, I can't fault you, but I just like to put the whole pattern. Last one. At what x value or values does this function have a horizontal tangent line? We kind of just talked about it. That means the slope should be what? 0. So it means we're going to get the derivative and set it equal to 0. If this was a free response question, oftentimes they give a point just for writing that, even if you get nothing else correct. Which is kind of nice. That's like one nice thing that they do. All right, so what is your derivative of this? And be careful because there's just an x there, which throws people sometimes. That's 1 plus cosine x good equals 0. And then you just have to solve it. So what would you do to both sides? Yep, subtract 1. I should have picked a different place on the unit circle because this is actually the same answer we were just talking about before. Cosine is the x value. If that's negative 1, you're off to the left side, which is what on your unit circle? Yeah, pi. But you would also get 3 pi and 5 pi and 7 pi and 9 pi. Do you get what I'm doing there? You add on 2 pi, it's one full rotation. Okay, but usually they'll say something like on the interval 0 to 2 pi. I mean, you don't have to write that in there, but usually they'll give you like an interval so you don't have to keep going forever and ever.